All right, as people are trickling in, I will get us started. Good afternoon, everyone. Afternoon by 1 minute. I would like to welcome you to today's program, Aligning Budget and Energy Conservation Goals with Katie Irwin and Hannah Mullaney from Willdan. I would like to introduce our presenters. Katie is a project manager with Willdan and has an interest in energy efficiency and sustainable design. Katie joined Willdan last year, and she works with design teams, building owners, and utilities to optimize building performance through detailed energy modeling and comparative analysis. Katie received her Bachelor's of Arts, Architecture, and a minor in Environmental Design from the University of Minnesota. She is currently an allied member with the AIA Baltimore chapter. Hannah Mullaney is a project manager for Willdan and has been with the company for almost 3 years. Before joining, she was a student at Appalachian State, where she received a bachelor's in sustainable development. Along with project management, Hannah facilitates outreach and marketing for their energy design assistance programs in different markets. And for this webinar, be sure to add your questions to the chat box, and I will be reading them as they come in, or I'll read them towards the end. And in order to get your CEU credit, please fill out the form, and I will drop that in the chat box in just a moment as well. And with that, I would like Katie and Hannah to take it over.
Great, thank you, Margaret. Well, thank you all for joining us today. As Margaret mentioned, this is a live energy analysis charrette, and we're focusing on aligning budgets with energy conservation goals. And there's some faces to put with the names. I'm Hannah Mullaney, and Katie Irwin is my colleague. I work out of our Charlotte, North Carolina office, and Katie is based in our DC office.
Great, thanks, Hannah. Well, everyone, just a little bit about Willdan. We are a nationally recognized energy efficiency consultant, and we're working with 2 utility companies in Maryland, with Baltimore Gas and Electric and Potomac Edison. So both utilities are offering energy incentive programs for commercial projects, and we're focusing mainly on new construction and major renovations. There are some variations within each program, but the core focus basically remains the same. We provide energy modeling services, savings calculations, and we handle all paperwork for our customers so that they can get incentives when implementing strategies above and beyond the energy code. So we strive to make our process as streamlined as possible. As you can see, we listed out 5 easy steps. So we collaborate with the project team early during the design phases, and we hold 2 live meetings in order to evaluate the project scope and energy efficiency goals. That way we can run a whole building energy analysis, and this will help the team determine the best strategies for their project budget and the goals. And then once the project gets built, the utility company provides incentives based on the strategies that are actually implemented.
Great, thank you for that intro, Katie. And so just so you all know, I think Margaret mentioned that there will be a Google Doc going around that you can fill out with your AIA license number, and that way we can provide you with credits at the end of the completion of this course. So in this course, just to outline some of our learning objectives, we're hoping that you'll be able to recognize the value of early energy analysis in the design process, and help you identify a range of energy efficiency options and their impacts on energy outcomes. Also interpreting building performance and financial information provided by the energy analysis results. And we also hope that you understand how decisions made early in design can increase your energy savings opportunities. So just to outline the agenda and what to expect, We'll set the stage for the charrette that we'll be interacting with later. So this is a live participation charrette. And then we'll discuss the results of that charrette and evaluate the energy model and look at the trend data. And then we will review, I think we're getting feedback from someone. But then we'll review the built project and the actual project that was built based off the charrette that we are using today. Also throughout this presentation, we'll be using smartphone polling. And so just to test it out, if you all wouldn't mind texting J Huntsman 632 to 22333. Jay Huntsman is Jeannie Huntsman. She's one of our project managers, and Rich Pesky is also one of our colleagues. So don't let that throw you off. They are Willdan employees. We're just using their smartphone polling app today. So I'll give you guys a minute, and then you should be able to see this notification that you've joined Rich Pesky's session. And then we'll go ahead and test this out by asking you a question just to make sure that the polling is working properly. What superpower would you rather have? And you can text A, B, C, or D again to that 22333 number. All right, looks like time travel is in the lead. I think time travel would be nice, especially for 2020. All right. All right, yes, and we got some more uptick in the crushing deadlines with your fifth. That's a big one, yeah. All right, great. Well, it looks like the polling is working, so we can go ahead and move on. And Katie, I'll hand it back to you.
Great, thanks, Hannah. I thought the crushing deadlines was going to win, but that's, I was wrong. Yeah. All right. Well, thanks, everyone. So why is energy efficiency important? And how do we get to a clean and cost-effective energy future? Well, we know that reducing the energy consumption of the built environment is vital to success. And as design professionals, we have an important role to play in cutting down consumption. So could it be as easy as adding solar to every rooftop? Well, unfortunately, just adding renewable energy generation without first implementing energy conservation measures can have detrimental effects to the grid, which is why we need to exercise our creative problem-solving skills in order to reduce the load of the building as much as possible.
I think I need to clear out his responses. Okay, so what types of projects tend to implement more energy efficiency measures, do you think? We have residential, commercial, retail, civic, institutional, and industrial. Yeah, so noticing the trend here, institutional is definitely one of the more, the bigger sectors that we see implementing. You see a lot of schools implementing more energy efficiency measures. You don't see it as much with industrial just because the energy codes are a bit more lax. And manufacturing, if you're thinking in terms of manufacturing, there isn't a lot of potential a lot of times for energy efficiency measures. But we do see a lot in commercial and residential as well. Civic is also one of our bigger sectors that we do see a lot of energy efficiency measures.
Okay. So in our discussion today, we'll be talking a lot about EUI, which is energy use intensity. And so for those of you that aren't as familiar with it, EUI is a key performance metric to understand how buildings use energy. As you can see, it's measured in kBTUs per square foot per year. And you could consider it similar to miles per gallon in a car, but in this case, you would want the lowest number possible for your EUI. Okay, so how does EUI work? Well, as you can see here, we take all energy needs in a project such as the heating, the cooling, the lighting, basically anything that's going to make your meter spin. And we divide that energy consumption by the square footage of the building. And by doing so, this normalizes the value independent of the size of a project. So we can compare the efficiency of a smaller building to that of a larger building on a per square foot basis. And that resulting number will give you the EUI. Well, looking here, we have the site EUI and source EUI. So you might be familiar with the difference between the two. The site EUI looks specifically at on-site energy consumption, whereas the source EUI also takes into account the efficiencies in generation and transmission. But for today, we're going to keep it simple, and we're just going to look on the on-site EUI.
So where do we start with our energy efficiency strategies? So far, we've talked about energy in the big picture on the grid and at the site. Now let's move into building and talking about efficiency. As an example, here are a few strategies you might consider. And here are some more, and some more, and more. And pretty soon you're overwhelmed and you don't know where to start. So how can you cut through it all? Well, we recommend setting your goal for your project first. Are you trying to reduce your cost for your client? Or maybe you have a lead goal or trying to get to net zero energy. Each one of these goals can send you down a very different path with your design. And the first step is to know what you are setting out to do. So once you're there, how do you choose strategies? I can tell from experience and practice that often teams will depend on rules of thumb or maybe rely on manufacturer's literature. Maybe we compare to similar buildings, or you can guess where this is going. We can leverage energy models to do the work for us. Sorry, I forgot to clear out previous responses, but this next question, so what is your go-to method for picking energy efficiency measures? Don't let us bias you. Great. Yeah, so we see a lot of different strategies out there and not necessarily picking on any of them, but we definitely lean towards more of that energy modeling strategy, just so you can get that whole building energy analysis. And Katie, back to you.
Great, thank you. And thanks everyone. Okay, whenever you're utilizing rules of thumb or manufacturer's literature, which I didn't see anyone choose, or comparing EUIs of other buildings to your design, it's important that you're comparing apples to apples. So here are some important variables to keep in mind, making sure that you're doing so, such as climate, the building type and size, the window to wall area ratio, and of course the hours of operation. And as we evaluate your energy model, what we're looking at are those optimal groups of strategies that will give you an idea of the potential for your project. So unless cost is no object, you're probably not trying to get the most efficient building out there. We understand that you're trying to align those first costs, the energy cost savings, along with your design goals. So as you can see with this graph, we're illustrating a building's potential with 3 scenarios above the energy code. Good is usually where your current design already sits. Better would include those incremental strategies, pushing you even further above the baseline. And best being those, stretch goals with the best EUI and the best energy cost savings calculations out there. So what we're trying to help you find is that sweet spot that gives you the biggest bang for your buck. And so by starting early, you'll have the greatest opportunity to maximize your savings when you're starting in schematic design and design development. First, by minimizing the energy load through efficient massing, judicious use of glazing, followed by implementing simple cost-effective systems such as the HVAC design, the lighting, daylighting controls. So applying these measures will minimize your base load and will have less impact to the grid. And of course, it's important to remember that at the end of the day, people will operate the building in ways we can't always predict. So what goes into a comparative analysis? Well, as you can see here, we take into account several variables such as a building's geometry, the hours of operation, assumptions on how a building is to be operated and occupied, an average weather file. And so all of these factors are then compared against the minimum requirements of the code baseline, which ultimately produces the energy model results. But with everything that goes into these models, it's important to remember that combining the effects of energy efficiency strategies isn't additive. It's not straight addition. So 2 + 2 doesn't always equal 4. It sometimes equals 3.25 or 3.1. And that's because we have a whole building and systems approach. We're taking into account how these strategies interact with each other.
So let's get back to that long list of energy efficiency measures. With some energy modeling tools, it's possible to study every one of them, but in the interest of time today, we're just going to narrow the list down to 6 categories and see which might be the best for a sample project. So we're going to be looking at building massing, envelope upgrades, lighting controls, HVAC systems, demand controls, and energy recovery. A little bit about the project that we will be discussing today and using for this exercise. This is based on an actual project that came through our office. It's an elementary school with typical programming, typical uses, and typical hours of operation. The project is located in the heart of the Midwest in a climate zone 5A. So think really cold winters, hot summers, and all too short of shoulder seasons, which one of our Midwest colleagues made this, and I'm from North Carolina, so I don't know what a shoulder season is. But keep in mind that only parts of the school are occupied during the summer months. And without delving too much into the different strategies, we're just gonna give you a pop quiz. And so there's no background here, there's not supposed to be. We just want you to make a guess, your best educated guess on what the best combination of strategies will be for this building. So anything with a check mark beside it will be a system or a strategy that gets an upgrade. So for example, for option A, the envelope will get an upgrade and daylighting controls will get an upgrade, but every other strategy would remain basic. So same with B, they would get compact massing and envelope upgrades. So let's go ahead and jump into the poll and let me clear the responses again.
Real quick, Hannah, some people were having trouble connecting to the Huntsman. So are they texting to the 22333 number and then they text Huntsman to that number?
Yes, yeah. So if they text that, it should log them in, and then they're able to answer with A, B, C, or D.
Okay, do they get confirmation or anything?
They should get a confirmation.
Okay, we had someone having trouble. Maybe this will help.
Okay. Yeah, let me know if it doesn't.
Okay, thank you.
Thank you. All right, so we'll give it a couple more seconds, make sure everybody can answer. But just to revisit, it looks like B, C, and D, no one guessed A. So most people were leaning towards upgrades to the compact massing and envelope upgrades and the energy recovery. All right, so now we're gonna jump into a little bit more detail, and we'll ask you the same question again with a little bit more knowledge, so you can reevaluate your answer if you want to, or stick with the same one. So think back to those 6 energy efficiency conservation measures we talked about a few minutes ago. Right now, we're going to go through each one of those strategies, review the options you'll have on the table, and we'll talk about some of the energy data you'll use to inform your decisions. Then we'll let you discuss and select which option you'd like to use in each category. So the first option on the table is the building massing. On the left is the dispersed form. It's a floor plan that's focused on views, daylight access, and visual interest. The alternate on the right is the more compact form. And the user experience aside, moving in this direction could have some potential for energy savings. And so when we move through this, this charrette, you'll see that there are dollar signs at the bottom. We'll give you a budget of $12 for your budget. And so these correlate with the different design or different strategies that you select. So in this case, for the building massing, the compact form is the less expensive, and the dispersed form is more expensive. Another decision we'll be looking at is the makeup of the envelope. We are using fairly basic insulation and glass on the left, or we're upgrading on the right. And so again, you can see that the upgraded option correlates with a higher price tag. And then for the lighting controls, you can choose to have the occupancy sensor or vacancy sensor control, or you can go with the daylighting controls. And then with the HVAC, you can go with VAV with air-cooled chiller and gas boiler, or you can go with the geothermal option. And for the HVAC demand controls, you can go with standard controls or demand controls with CO2 and occupancy sensors. And last but not least is energy recovery. So you can go with no heat recovery or total heat recovery. So now, given the savings range and a little bit more breakdown of those different strategies, you can go ahead and pick your selection again, A, B, C, or D. I'll give you guys a second on this slide to look at it. All right, great. So we will go over these strategies and pick the best. So B and C were our top two choices. So we'll start with B since that had the highest amount of votes. And Katie, would you mind letting me know which ones from B we should select?
Yeah, sure. So for B, we had the compact massing, the envelope upgrade, basic daylighting. They went the VAV, basic demand controls, and energy recovery was selected.
All right, so we used our full budget, and let's see what that did in terms of savings. All right, got it on the first try. So you can see here that this was the highest in terms of annual energy saving costs. So we kind of look at this in terms of tiers. So this puts you in that first tier, and then the second tier is over here, third tier, and then we trickle down to a fourth tier. So this does have great EUI, a great EUI number as well. You like miles per gallon in a car, you do want that lower number. However, it does rank 10th in terms of the EUI. So just because it gets you the best annual energy cost savings, it doesn't necessarily mean you have the lowest energy use intensity. But peak savings, it did really well too. It ranks 4th with 34% peak savings. So we'll go back and then we'll look at what C looks like. So Katie, if you could do that again.
Yeah, no problem. Okay, so for C, also went with a compact massing, basic envelope, basic daylighting. The geothermal was selected, basic demand control, and there was an upgrade in energy recovery. Oh, so the demand control is basic.
Oh, the demand control is basic.
Redo.
I know, it doesn't let me unselect. Did you say lighting controls were basic?
Yes.
Okay, and they had
geo.
Great.
Yep.
Yeah, it doesn't let you overspend your budget. All right. Unfortunately. All right. So now this selection did give us the best EUI. So it brought us down to 32.4. So again, the savings don't always correlate with the EUI number. Still pretty great savings. You're still considered in that first tier of annual energy cost savings. And then in terms of peak savings, this was a little bit lower at 11%. But still pretty great overall. And when you're thinking about this in terms of a school, a lot of the times their main goal is those annual energy cost savings. So this would be a great strategy to select for your school. So in the interest of time, we can go ahead and move forward and not go over all of the answers. I think I will select D. We can just show them D really quickly, Katie, because that is what the school ended up going with.
Right, which was that dispersed form, basic envelope, upgrade for daylighting, the VAV system, upgrade for demand control, no energy recovery.
So you can see here, they didn't use the full budget in the real life project that was constructed. And so that put them down here, kind of towards the end of the third tier, kind of upper fourth tier. So not the best EUI savings, but they still did save about $34,000 in annual energy costs. And then their peak savings were still pretty great at 31%. So now we'll look at all the different different strategy combinations and some trends on how specific strategies played into the overall results. This graph of every possible outcome in this exercise, each bar here represents the savings results from one combination of strategies. So here you can see with the dispersed building form combinations, you could really have a wide variety of savings potential. This all, again, just kind of refers back to what Katie was saying about how everything 2 plus 2 doesn't always equal 4. So how the systems interact with each other in the dispersed building form can make a big difference in terms of your savings. For the ground source HVAC combinations, that did put you in a higher tier. For most combinations, you were either in a higher or a lower tier 2 or in that first tier. And then for demand control combinations, again, this varied in terms of what other strategies it was paired with. And energy recovery for any strategy was going to put you in that first tier of savings. Envelope upgrade combinations, again, this was one that differed based on those system interactions, as did daylight control combinations. And these were just lower cost combinations that for your budget. In terms of the $12 budget that we gave you, these were what you could have had in your project. As you can see, there was really only one option that would have put you in that first tier.
All right. Well, thanks, Hannah. So we'll dive a little deeper as to how the project results shook out in the end. And as Hannah gave a preview of what that of what they did, but we'll just give a little more detail. All right. So as we mentioned earlier, the optimal time to maximize on those savings would be during the schematic design and design development phases. Again, first taking those steps to minimize the load, and then followed by implementing simple, cost-effective systems. And of course, by the time a building becomes occupied, it's key to remember that people will run buildings in ways that we probably never imagined during design. And so referring back to our SPARK polling, the project team went with option D, and they basically focused on those daylighting controls and HVAC demand controls. And with this next slide here, they went with that dispersed form, the basic envelope strategy, selecting the daylighting controls, demand controls. They did not go with the energy recovery simply due to maintenance being an issue for them specifically. And they went with the VAV system initially, and then we checked back in with them later on after the project was built, and they decided to swap out and go with the geothermal heat pump system. So going to show that it basically takes some time and practice for folks to get used to getting comfortable learning different systems. So they were able to earn some savings with that switch. And looking back here, before they went with the geothermal switch, this chart is showing their original energy cost savings with that VAV system. And as Hannah pointed out, there is still room for improvement in terms of energy cost savings in that EUI, as we learned through our exercise earlier today. So after construction, we were able to take a look at their meter data, and we compared the actual energy use to what was originally modeled. So the green area is showing that difference between the actual energy use compared to the modeled energy use, which is the blue shaded area. So we were, scratching our heads, why was the actual energy use higher in this case? And we learned there were a couple of reasons. One of them was that we had originally anticipated the hours of operation to be a lot less during the summer months. School is out and their summer programming wasn't that all too intense. But it turns out the community really liked having a new building and, scheduled more events during those summer months. So that wound up increasing the energy use. And then another factor that increased that energy use during the school year was that they had disabled all daylighting controls. One of the teachers basically, the lights weren't working in their classroom and somehow just decided to turn off all the daylighting controls, and that, increased the energy usage. So the good news is that after that was realized, the controls were recalibrated and, things were up and running again. All right. So if you've learned that the energy use of your project has changed, there's no need to panic. Here's some common reasons that we've learned as to why the meter might be different from the model. And hours of use is pretty much one of the top reasons. Maybe the space is being used differently than you expected, or if you didn't anticipate those higher plug loads, that is a common reason. Perhaps the controls had been overridden or the calibration is off, just as the school is a prime example of that reason. And sometimes equipment malfunction happens. It's a rare occurrence, but it's something worth to look into if those energy uses change. And so as we're drawing to a close with our presentation, here are some key takeaways when evaluating a project's energy potential. With every project being different, it's important to establish those energy goals early in design, especially when utilizing model data to support your design decisions. So partnering with your electric providers does help you take advantage of energy consulting services. And of course, it's key to remember that people run buildings differently than expected. And here's a quote that we like to leave with you today by Donald Watson. Energy is a design topic, not a technology topic. Just a good reminder that energy use is a challenge that's in the hands of the design professional and that there are tools available to help us solve it. And that concludes our presentation, and thank you all very much for joining us today.
Yeah, thank you. And we did want to leave time for questions at the end, so I don't know if any had filtered in.
Yes, we do have one right now, and it said savings are measured in dollars with no consideration for associated carbon emissions. Is that, Viran, did I do a good job asking that? Or do you?
So the savings are considered by a dollar amount instead of carbon emissions? That was the question?
Yes.
Yeah, no, so that's a great question. So it does depend on your goals. So for example, this school project that we used, we find a lot of the times they are more focused on saving money as the money goes redirected back into educational purposes a lot of the time. So that's why we mentioned earlier on that it is something we'll work with your team on. If carbon emissions are your goal, then that's what we'll focus on more in our energy modeling strategies.
And we have another question. Could the energy model be reworked to add more options to building use?
Yes. So we kind of consolidated this energy model for the purpose of time. If we went through every strategy, this would be, well, you'd probably get all your credits you need for educational purposes if we went through all the layers. But we use our software called Neo, and that does break down buildings in different space asset areas, and we look at a lot of different variables. And then we have a different energy modeling program that we use for more complex models that we call File Builder. And this just adds layers of every different strategy you could implement. So again, it really does depend on which project that we're looking at, but we do try and take into account the whole building energy analysis.
Will your model readily forecast both energy cost in dollars and carbon emissions for the same selected criteria?
Oh, I'm sorry. Could you say that again?
Will your model readily forecast both energy cost in dollars and carbon emission for the same selected criteria?
That's a great question. I can't speak with full confidence on the carbon emission side. Most projects that I've worked with do focus more on the savings potential. Like we mentioned too, we work with utilities, so a lot of their focus is on the incentive that they get from the utilities and the money side of things, but we do try to include the carbon savings as well, and we'll focus on that if that's something that the client wants to pursue more. So long story short, the model will show both. It just depends on what factor you want to focus on.
Right, and I'll just add, we do have programs in Minnesota with those utilities, and one of their criteria that they do provide for customers that go through their specific program is showing the carbon emissions savings forecasting, if the customer wants to know that information. So the model can provide that type of criteria depending on what how you want to evaluate your project. And that's what really the ultimate goal is, because every project is different. Every client has different priorities. So.
Sure. If you have any other questions, please add them to the chat box, and I'm going to send the form list or the form document once more. And a little while ago, I also sent a link to the to Will Dan's website for more of your CEU programs. There's the form. Do you find that the local utilities, BG&E and PEPCO, encourage or discourage analysis of carbon emissions?
That's a good question. And first, to clarify, we are working with BGE and Potomac Edison, so we're not working with PEPCO. And that is something we are not primarily focusing on, but it's definitely not something that is discouraged. It's just something that hasn't been at the forefront of what we're providing our customers. But it's a great question. I'm happy to bring that up with our program manager, if that's something that's of interest to you.
All right. Thank you both, Katie and Hannah, for the presentation. I don't see any more questions coming into the chat, so I think we're probably done. If they do have any questions, your contact are on the screen. Oh, we got one more. Are your services provided to clients at no cost?
That is a great question. So with Potomac Edison, there is no cost to our customers. And we do provide an incentive to the design team for their time spent going through the program. Through BGE, there are some variations in terms of with the criteria. Just there's a few tracks through that program. So depending on your project, there may be a small fee associated, but for the most part, we will be able to waive that for our clients. So it's pretty much a case-by-case basis. And I'm happy to talk more in detail about those specific projects.
Awesome. Well, thank you. This was a great presentation for today. And if anyone has any other questions, you can email Katie and Hannah.
Great. Thanks, everyone.
Have a good rest of your afternoon.
You too.
Bye.
Bye.